Hey guys, welcome back to another KevCAM night class tonight. Tonight we're doing something a little bit different to accommodate some scheduling and stuff like that for a special guest. We're actually doing kind of a pre-recording for you guys, so you guys that are used to watching this live, unfortunately we couldn't do it, like I said, for scheduling for Ahmad, but I wanted to get him in here for you guys to show you all the new features that are inside of the simultaneous 5-axis, more geared towards the new multi-axis constant Stepover machining that they have put in there for you guys for 2019. So with that being said, I will hand it off to Ahmad and let him take it over.
Hello everyone. It's been a long time since we met on the webinar. Oops, sorry, this is a new interface and I have no idea how to minimize it. Here it is. Okay, sorry. So this week I'm going to spend time on 3 subjects. First of all, some small areas of change that we did in 5-axis, in simultaneous 5-axis functions. The main topics today are going to be, I'm going to talk about a new machining strategy that we introduced in 2019 on SP1, and also we released the much talked about support for tools called the circle end mills. A lot of people were asking about it and the facts and myths attached to these tools. We're going to talk about that. Also, I'm going to show to you today a part that we did against Hypermill and against Concepts NREC. We won. We got the order against these 2 very powerful systems. So I'll just explain to you how we went about doing it. So these are the 3 crucial areas that we are going to look at today. First of all, the small functions that we introduced in 2019. First of all, we introduced a function called as gradual front shift that was already there, but it was not known as gradual front shift, but it was just known as front shift. And what happens here is that this feature allows you to shift the contact point of the tool from front to the back as it progresses over the surface when it is machining. If you ask me where is the application is basically if somebody would like to have contact on both the sides of the tool, especially when they're using disc kind of cutters, or let's say they're polishing a surface in 5-axis and they would like to use the front and the back of the cutting tool, then they can use this function called as a gradual front shift. It's a very small function, but it can be very useful in situations where you would like to make both the points of the tool engage on the surface. We also introduced a different feed rates. That means you can now control the feed rates on the links, basically, like Stepover. You can have a different feed rate, or when the tool is entering into the material for the first time, you can have a different feed rate, or every time the tool lifts up, you could have a different feed rate. It could be applied over a spline, or it could be applied directly using the direct links. So another small but nice enhancements that we did with 2019. With the smooth toolpath, we introduced a new function. Earlier, when you look at rounding, okay, what used to happen was only the last pass used to get rounded off, or the final pass towards the surface used to get rounded off. Now, if you did multiple passes, there was no way you could round it up. Now we have introduced this function where you can do smoothing or rounding off of the toolpath. So let's look at these 3 features in our software, how it works. Let's open the front shift part. Sorry. Okay, so I have this simple surface, and this is my toolpath. Now if I look from the side, okay, let's go to the side and look at how the tool moves. So if I run the host CAD, you can see that my first contact is out here, and as it progresses, okay, as it progresses, you know what, let me change the tool size so it becomes more evident. So I will change the tool to T1, a bigger tool, makes more sense now. So now if I run the simulation, you can see that my center of the tool is in contact with the surface, and as it moves, it's always the center point that is in contact. Okay. Now, if you go to the option of front shift here, tool axis control, tool contact point, and if I say I would like to have it at the front or at an user-defined point, in most cases front, so I'll calculate, and this is how the tool contact happens. Front, and front. The back doesn't still get into, doesn't create, you can say, it doesn't create a contact. So what you have now is, you can see the strange connections. That is because the contact here is over, the next contact starts here because it needs to make the next contact here at the front. So it switches the contact point. But if I use the same toolpath, and in the advanced, I can use the user-defined point, and I can say that start the first contact point at plus 50. My diameter of the tool is 50 diameter, so it's going to start at the front, plus 50. And by the time it ends, so we have got a new parameter here called 2. I'm shifting the contact point to minus 50. That means from front to back. So if I now show you the simulation of how this looks, the front to back, you will see that the first contact point is front, and as it finishes the machining, the last contact point is on the front. Okay, so this is a new feature. What we can probably guess is that you can use it especially in applications related to polishing where you would like, or in disc cutters where you would like to have cutting on both the sides of the tool. So this is how the tool path looks like, pretty clean. Okay, not the strange connections that you see when you just use the front shift. Right, about the next option, we can even see it right here. So I will edit this tool path and remove the front and make it auto, and in the link I'll use a blend spline. Let's calculate, and you can see that now I can put a different feed rate for my stepovers or links between slices. Also, when I'm using the gap, I can put a different feed rate. So if my feed is 1000, whenever it's going to take a step over, okay, whenever it's going to take a step over, the feed automatically will drop down to 500. You can see that the feed is now dropped to 500. It's because it's taking a step over. Again, a small change to our toolpath engine. Let's open another one, and that's the smoothing. Oops, not the SLDPRT, sorry. Okay, so I have a toolpath which looks, which I've used parallel to curve. Okay, and how my toolpath looks? My toolpath looks like that. Now, if I use, for example, if I use the corner rounding, it's already rounded here, but if I still want to round the corner, and if I say use a round corner of 10, I expect that it will do rounding on every bit, on every toolpath. But what happens is only the final tool pass is rounded out. The other passes are not rounded. To fix this, we introduce this new function called as smooth toolpath. So I can go into the smooth toolpath and switch that on. Now, we're going to change this. I just noticed it a day back. It's basically the smoothing distance and the detection angle. So what is the smoothing distance here? The distance is basically calculated from this point. So I have put a value of 5 here. That means 5 millimeters. So it will calculate 5 millimeters from here. It will drop a point. So I'll get a point here. 5 millimeter from here, I'll get a point here. And these 3 points will be used to generate a nice smooth curve or a nice smooth arc that will then be, or at this point, the arc will be tangent to these two tool paths. And the other option here is the detection angle. So I'm asking that anything below 20 degrees should be detected, okay? Or rather, anything above 20 degrees. So I've used 5 millimeter here. This is not the corner radius. It's basically the length at which the corner radius will be tangent to the two tool paths. And if I run the calculate button, this is how my toolpath will now look like. I get the rounding in the entire toolpath that is running on the entire part. Okay, so it doesn't just do the last toolpath, but it does on the entire toolpath as long as it has the passes. So 3 small enhancements that we did. You're going to see this. These are already there inside it. But what you don't see here, probably in the version that you've already downloaded, is the tool axis control. We have made some changes to the tool axis control, okay? So you will see that changes coming up in the hotfix soon. Those changes were necessitated for using our new type of tools. Okay, let's get back to our presentation. So we have 3 small improvements, significant improvements. And then we introduced a new toolpath strategy. It's called as MultiAxis constant Stepover. What is the strategy all about? With MultiAxis constant Stepover engine, SolidCAM will now provide an evolution. It's like a revolution in the field of pattern generation. Remember, this is not completely new. It was already there inside SolidCAM, but it's been now moved out, and some special things have been added to it, and we have created a completely new kind of technology. It's basically a new pattern generator that we have introduced in SolidCAM 2019 SP2. With this pattern generator, SolidCAM uses a global distance field. That means if I put a Stepover of 0.5 millimeter, you can be assured that you can measure 0.2 of 0.5 millimeter between any of the toolpath strands that you can see. For example, you can see on the right-hand side, we just selected 2 curves. It's a 5-axis toolpath, and I've used a Stepover of 0.5, and it generates 0.5 continuously till it meets the end of the curve. From starting from one curve, it goes right up to the last curve. Now, the best part about this particular function doesn't just work on surface, but it also works on a mesh. That means you could provide an entire model to it and just provide few curves, and it would create a toolpath with a constant Stepover between all the curves that you have provided. So it doesn't matter whether you're working on surfaces or whether you're working on meshes, you will get a toolpath with a constant Stepover either on a mesh data or on a surface groups data. It's a very interesting thing. I'll come to the when I come to the end of this this particular strategy, I'll explain to you what we are going to do now more. So in an undercut situation also it works excellent. In an undercut situation, it still maintains a constant step over. Okay, for example, you can see a best portion of and best part for an undercut. It's continuously changing. From here, it goes into an undercut, it comes up, and then it enters inside also as an undercut, and then finishes at the center. When you look at this toolpath, you'll probably be amazed because this is selected as a mesh data and not as individual surfaces. It's just selected completely as a mesh. You can also select as individual surfaces. It will still treat it like a mesh and generate passes with constant step over. Whatever step over you have provided, it will maintain that step over on any situation, whether it is machining in this region, or whether it is machining in this region, or whether it is making a transition from this surface over the fillet into this surface. It will still maintain the step over constant at any given point on the part. So one example. Another example is over here, where you have a cutout with fillets on either side, and what it generates is an excellent toolpath starting from the fillet and ending up onto this edge of the surface. A single toolpath with absolutely beautiful tilting. Now, when I come to the subject of tilting, I'm not sure if many of you have started using the automatic tilting option. Automatic tilting option has matured a lot in the last 1 year, and today automatic tilting is highly reliable. Even in a very tight situation, it works very nicely. For example, in most of the parts that I'm going to show to you today, I've used auto tilting, and it works very nice with auto tilting. It goes very close to the distance that you have specified as a clearance in our clearance data tab, and it machines the part without any collisions, either with the tool, arbor, or with the holder. So it gives you consistent and reliable results with the auto tilting. So multi-axis constant step over coupled with auto tilting gives excellent results. I'll show you the parts. What we did was I started checking this toolpath engine on 3-axis parts, simple molds or cavities or parts like that, to check what is the quality of toolpath that I generate out of this particular engine on 3-axis toolpath, and the results were stunning. You can look at on the left-hand side, I have machined the entire part just using 2 curves, and this is machined on the mesh data and not surface data. I just used the external curve and the internal curve, and I said generate constant step over toolpath, and it did excellent machining on the entire surface without even lifting once. I tried the same thing using HSM constant step over and also with turbo constant step over, and I could see several lifts here at the center, several lifts here, and so on. So if you compare the toolpath, even on a 3-axis level, the toolpath gives stunning results. I moved it even more further into another tight area where I wanted to machine parallel to this outer curve and go all the way inside, and it just did amazing toolpath. So what we decided after we evaluated this thoroughly on 3-axis is that we are going to create a new subset of this particular engine just for 3-axis. Okay, so 3-axis customers can have the power of generating consistent constant step over toolpaths on their paths. Again, works on mesh, also on group of surfaces. Now if you look at the entire toolpath engine that I have just presented, there's nothing new in it. Well, we'll go into it. There's nothing new in it. It's already there in bits and pieces in several toolpath strategies. We have made a nice collation of the entire strategy to give you one single look and generate consistently nice constant step over toolpaths. So where can you use it? Where the application is limitless. You can use this, if you ask me where can I put this application to use, you can use this wherever you've used morph between two curves and parallel to curve. Wherever you have used these two toolpaths, you can substitute these two toolpaths with a new engine, with a new toolpath engine, which is multi-axis constant step over. Okay, so let's look at some of the paths on how we work with. Let's open part 2. Nope. Okay, so we have this part here, and if you look at the first toolpath, I selected a group of surfaces. Okay, again, this is really unheard of. If you're talking of 5-axis machining, you are actually not allowed to select these fillets and the surface together. It creates a mess, right? So what you get now is something unimaginable. So we have selected a group of surface here, and I have selected my tilt lines. That's how it's going to be tilted to, and I have selected the curve to which all my passes will be parallel. So I'm going to go parallel to curve. And the result is this. Consistent toolpath step over. Anywhere I check whatever is the toolpath step over, that same step over is taken all the way till the final. It can't generate any more step overs. Okay, so if you look at the GUI itself, it's very similar. We have, I mean, if you compare it to our generic 5-axis, it's very similar. You have the geometry selection. You can either select a model, entire mesh, or you could select a group of surfaces. Again, in the machining, you can machine the entire area or by number of cuts. Direction, you can either go step 1 or step 2, either from out to in, out, and start on guide. And then you have the pattern. You can go parallel to multiple curves, or you can go morph between two curves. Now, even when you say parallel to multiple curves, and if you have selected group of surfaces, not model, but group of surfaces, you can ask SolidCAM to directly detect the curves to which it needs to be parallel. So it knows the open areas, and it starts generating the curves by itself. So there are several methods by which you can generate the toolpath. One of them is automatic surface boundary. It'll find the curves by itself, or you could define the curves yourself. It's like an user defined. In the toolpath boundary, or in the toolpath parameter, sorry, you can have a constant step over. In this case, I defined the scallop that I need, and the step over was calculated. It is going to consistently maintain the step over, okay? Or you could put a maximum step over, okay? So if you're going to provide a scallop to it, then it's better to provide a maximum step over. If you would like to have a constant step over, then just calculate the nearest possible step over by putting in the scallop value, and it'll maintain that step over consistently on the entire part, okay? The other things, for example, the tool axis control, everything is same like generic 5-axis. What actually has changed is only in the geometry definition, okay? That's where is the change. And of course, in the Gauss check, I have not used anything, because when we defined the tool, I can define the calculation mode here. There's a contact mode, and then there's a tool center mode. If you go back again to your generic 5-axis calculations, whenever you don't get good toolpaths using the auto mode, okay? So if I go here and add a generic toolpath, okay, let's select a tool, otherwise it will not ask me. Okay, let's select this tool. So if I go to tool axis control, Whenever I've used the auto contact point, you'll see that at times the toolpath is not good at all. And you don't know what happens, especially when it is going in corners. The toolpath behaves something very different, okay? And when problems are reported, then many times I have advised that don't use the auto mode, but use the tool center mode. And you get very good results with tool center mode. The only thing is that you need to provide a proper gouge check when you're using the tool center mode, okay? So in multi-axis constant Stepover, by default, we are always going to use the tool center mode, but the best part is that the gouge check is done automatically inside when you're using the tool center mode, okay? But in spite of that, if you would like to put some gouge checks, especially if you have some check surfaces on the side, then you can provide additional gouge checks to it. But if you're using the tool contact mode, then you have to be very careful that you need to provide proper gouge checks for the tool paths, okay? But by default, we are always going to use the tool center mode, and that gives us very good results. So now, this was one portion of the part. What happens when you want to do right from here and go all the way up to here, okay? So here I have defined the entire part. And what I've done is I have, again, defined two curves. That's one curve, and this is the second curve. Based on these two curves and the same tilt lines that I used previously, I generate a tool path, and that looks something like this. You can see that one entry, one exit, and consistent Stepover right from start to the end. Okay? Absolutely no lifts anywhere, and it's a spiral toolpath, so you won't even see a Stepover coming in between. Very nice quality of toolpath all the way up to the edge of the surface. So you can see now the applications where all you could apply this this scenario. Like I said, any parts that you have done with parallel to curve or morph between two curves, you can easily substitute it with multi-axis constant Stepover, provide multiple surfaces including fillets, and it will give you a very good results. You don't need to split geometries and do all those stuff that you would do probably with generic 5-ax. Okay, let's look at another part. Sorry. We'll look at this part here. Yeah. So what I have here is a part with a cutout, and if I take a slice of this part, something like this, you can see how the part is. It also has circle inside, so it's like a spear with a thickness. Okay, and what I have done here is that if I go into my toolpath, I have just selected in the geometry the surfaces that I would like to machine. It starts from this fillet to the inside surface. These two surfaces have been selected, but if you look at the pattern, I've used morph between two curves, but I have not specified to SolidCAM which are those two curves. I have asked SolidCAM to find them automatically for me, okay? And the tool that I've used here is, if you look at the tool, it's a lollipop tool, but it's a pretty short tool. You can see it's just 25 millimeter out of holder, and I have got a shrink fit holder here. And if you look at the toolpath that it generates, it's pretty neat. Right from start to end, it has generated consistent Stepover. And if you run the simulation, that's more interesting because the auto gouge check or the auto tilt in gouge check works like a dream. Okay, let's increase the speed. That's how it will go. And the best part is when the holder enters inside. When the holder enters inside, you can see that it's nicely leaving the gap that I've asked it to. And it will do the same till it reaches the end. So my advice to you is start using the auto gouge check. It works beautifully. It will give you consistent results and, most important, very reliable results. Okay, the auto gouge check works very nice now. Right, let's look at another part. Okay, for some people wondering what is Mexico, it's not, the parts have not come from Mexico, but this particular tool path was codenamed Mexico when we started developing it. So that's how the parts have been named after. The parts have not come from Mexico. Okay, this part is even more interesting. It's like a cup. So I have got surfaces that go like that and all the way inside. So if you look at the cut, this is how it looks like. Okay, and now again here I've defined the surfaces. I've picked all of these surfaces, and here I have asked SolidCAM to go parallel to this curve. Okay, it goes parallel to this curve, machining everything that has been defined to it. The tool that I've used here is basically a lollipop tool, if I'm not wrong. Okay, it's a lollipop tool. So this is how the tool path looks like now. Single tool path, right from start all the way till the end inside. You can start applying your brains and now start looking where all you can use this kind of an application. So if you look at the simulation, this is how it will simulate the tool path. Absolutely no collisions. Wherever you stop, it's exactly leaving the space between the holder and the part. The tilting is done automatically. Even here, there is a nice gap between the part and the arbor. So as it goes up, it's continuously winding itself onto this entire part. And that's not all. It does the same thing when it goes over the fillet. And as it goes inside, again, it starts tilting. Again, here we have used the auto gouge check, auto tilt, and you can see that it's again leaving nice space between the holder and the part itself. Single tool path. The advantage of giving a single tool path, you get consistent surface quality. You don't see mismatches coming in. That's because you've used the same tool right from start to end. Now, if the same part was to be done with a ball nose tool, and that too a short ball nose, okay? I'm not using a long one. If you look at the tool, it's a pretty short tool. Pretty short tool. It's a 16 diameter ball nose with a shrink fit adapter, and the tool path also comes out beautiful. Single tool path. Okay, if I run the simulation, this is how it will run. Again, gap is nicely maintained. Like I said, you can use this wherever you have used parallel to curve or morph between two curves. You can use this. Now, I told you in the beginning that this was already there in the toolpath engine that we have. So where was it hidden then? This was hidden here. I don't know how many of us have already used this, but I use that option quite consistently. If I add a generic 5-axis toolpath, if I go to morph between two curves, and if I go into toolpath parameters, you see the Stepover calculation here. The approximate is the one that we have been using for years now. There's a new one that could be introduced called exact. Exact uses the multi-axis constant Stepover engine at the back end, and that's how it generates the passes. Okay, but it was only using a very small subset of it. for the pattern. But here we have got a completely new engine which uses that particular technology. In fact, that exact technology is borrowed from MultiAxis constant Stepover, but it's applied here in a much deeper way in this particular toolpath. Right, so you can now start experimenting. Only one thing, in the versions that we have introduced after SP2, especially for people who are doing the development version, they download and the test, please be aware that we have removed the 3-axis option because we are going to completely create a new subset toolpath for 3-axis. But for people with SP2 who have downloaded 3-axis toolpath, still exists there. You can experiment this toolpath engine on your 3-axis paths, cut them, and let us know the results, because we have got consistently very good results with this particular toolpath.
All right, thanks, Ahmad, for doing that great presentation on the new multi-axis constant Stepover and a little bit of the kind of what's new with 5-axis machining. Now, going forward, we are doing a SolidCAM World coming up. And this is only for resellers, so unfortunately customers can't go to this, but coming up in the next week or 2 weeks here. So we won't have night classes for you guys for the next couple weeks just because we'll be so busy doing that. So once we get back from Florida, and we'll get back rolling again with the night classes for you guys. So like I said, give it about 3 weeks, we should be back, and we will actually be covering the barrel cutters, lollipop cutters, and double barrel cutters, and all the new cutters that you guys can use inside of the 5-axis for 2019. And Ahmad will be helping us out with that as well. I just wanted to bring Ahmad in here just because he is the definitely the guru on 5-axis stuff. So for you guys, you would get much more out of him than you guys would get out of me on this. So like I said, I apologize for being kind of a pre-record and not live for you guys, but if you guys do have questions, shoot me an email. My email is in the description of the video down below, and let us know what we can do to help you guys out. All right, guys, we'll see you in a couple weeks, and we'll keep you posted on the videos coming forward. Thanks, guys. Have a great evening. Bye-bye.